Hey everyone, welcome to another YouTube video where today we'll be building a robotic arm that will use and hold a cat laser. So here you see the product in action. My cats aren't really memorized by the laser, but they're more memorized by the product. But still, it's a cool, interesting project that I worked on. So here are the two lasers. The one on the left is the one that's functioning, and the one on the right will be the one I disassemble and show you guys how it works. So I have a two position switch, that can turn on and off the servos, whether it's powered by a USB to the computer or a battery. And the two servos are going to end up holding and kind of maneuvering the laser that's being held on that little snap clip. The laser is pretty cool. Just bought it off of Amazon, but just to show you guys it's functioning, and it's pretty secure when it's clipped into that kind of half circle design I have secured to the second servo for pivoting. So let's get right into all the parts and the assembly of this, where I 3D printed everything. So I have a 2-position switch that I use just to turn on and off the entire Arduino breadboard, so you can sort of control the servos when you want to power it on and power it off. Here is the 2 servo motors that are attached to their pivoting structures. They're being secured by kind of thin plates. I could have had proper dimensioning to secure the arms directly, but I figured this was going to be more simpler and sort of gave me more freedom with dimensioning my design. So as you see here, it kind of just is nice and simply clicks in, and it's pretty secure. And here's the other servo that is going to be rotating the base, and it will hold the other servo as well. But here's a better view of the plates that I used to secure the servo arm. The orange little oval pill-shaped pieces are the things that hold them in, and I use M3 screws to secure everything, ranging from M3-8 to M3-16. For the base that houses the Arduino and all the electronics, I also include this thin plate that will allow me to use the adhesive side of the breadboard and secure it to that orange sheet. And the orange sheet will be nice just because it's kind of removable. So even though I might not be using that breadboard for this project, I could use it and move it around and not have it secured to that base. I also have these aesthetically pleasing bumpers. They don't really perform a function aside from just being a nice little touch to the design. Here is a end cap to one of the servo housings, and I just have a cylinder on it to be another support system for that servo motor. So let's get right into the assembly. So let's start by just adding the 4 bumpers to the bottom of the main base. Now I'm going to work on securing and assembling the servo arms. So the first step will be to have the servos be conjoined to each other. So I'm going to have the servo pivoting base secured to the servo up and down base before securing it to the top plate. Then I'm going to insert it in the little slot of the top plate. And then once that's inserted, I'm going to use those 2 thin plates and secure them and lock the servo in. It was definitely a tedious design. If I were to go back, I would change some things, but it was a solution that was working, so I was satisfied with it. I'm going to insert the 2-position switch in the slot, and then once that's inserted, obviously I'm not including your breadboard or Arduino, but you can insert the top plate onto the base, and then lastly we'll secure everything by including the 4 top bumpers. And that concludes the assembly of this design. Now let's get right into the code. So here is the image of the circuits and assembly of everything. with the Arduino. So for the wire diagram, I utilized pins 7 and 8 for the servos that were the controlling the positions of it. Everything's powered to the positive and ground. The switch is sort of in the middle, so it powers the switch, which was pretty useful. So it didn't always just turn on or off once I supplied power to my computer. So for the Arduino code, here we have the library introducing the servo. I have two servos being assigned, servo 1 and servo 2, and they're going to be attached to pins 7 and 8. And then for the loop, I just have a repetitive loop of the servos being written and delayed to a certain degree. And the degrees and angles range from 115 about to 180. Primarily high values just to avoid the laser from moving so fast at various angles, just so the cats could kind of track it. And if it were to go to 0 to 180 so quickly, they would kind of lose it. So that's why I have the angles kind of grouped together at a higher value. So if you want to pause the video to see this code, you can kind of change the angles and even change the pause time as well. But to conclude this video, here's a little clip of my other cat being interested in the laser. You see him eyeing it up a little bit, but he's not really tempted to attack it at all. So I hope you guys enjoyed this little video of me working on an Arduino 3D printed robotic laser, and I hope to see you guys in another video here soon. Make sure to like and subscribe for more content similar to this, and I hope you guys have a great day. See ya.